I've told you this before, but you know what my favorite thing is? Redoing my notes because it was paused on the recording. Welcome to chapter 3, part C. We're doing I. Yes, that's lowercase. Yes, it kind of looks like a J that's backwards. Yes, it has a little tail on it. Do you know why it has a tail on it? Because otherwise it looks like a semicolon or just a letter I chilling. And yes, it is lowercase. I know you hate it. I know it should be capitalized. It's not. Get over it. Okay. Gauss, this old guy, dead, long dead. I don't know how long ago he lived, but he hated I so much he called it the shadow of shadows. It was like a secret thing. So here's why I is important. All of your life for 15, 16, 17 years now, maybe even 18 years now, you have been told that you can't take the square root of a negative. Well, if we could, it would be I. I is the square root of -1. It just is. If I take the square root of a -1, the answer is I. Also, conversely, if I square I, it equals -1 because I just undid the square root. Okay. It's I because it's imaginary, but it's not really imaginary. What we do is we hurt its feelings for so long that now we call it a complex number. It's real. It exists. It's in your electronics. It's in here. It's how like electricians do this all the time. It's crazy. It's legit. It's weird to me that my phone knows what I is, but I didn't until I was probably 16. I don't know how old I was when I was in algebra 2. So a complex number looks like this. It's 3 plus 7i. 3 is the real part. I'm a real boy. And 7i is the imaginary part. But you can graph this on an imaginary plane. You can see it in ohms. You can deal with it. And we can do some basic algebra with it. We can add, subtract, and multiply complex numbers together. I know, right? But really quick, let me tell you why the heck we care super quick. I'm going to tell you more next time when we do quadratic formula. But for right now, if I did the square root of 36, you know that one. You know it's 6. Or it could be -6. You learned that last time. It could be either one. Who knows? We write plus or minus 6 now. We don't want to write +6 or -6. We want to combine that, so we write plus or minus 6. Well, the square root of -36, that doesn't say 36. I'll do 60, nope, that's not a nice one either. 64, there we go. I wanted them to be the same thing, but I accidentally wrote 6 first. So if it was a -64, it would be 8i or -8i. And then what we write is we write plus or minus 8i. It's the same. It just tells me that I tells me that it was negative when it was inside the square root. That's all. All right, let's do some operations. This is arithmetic, so we're doing adding. So let's add two complex numbers together. Let's do 8 minus I plus 7 plus 2i. All we're going to do here is we're going to combine like terms. So I have this handy dandy blue pen here. I'm going to combine my like terms that are real. 8 is real and 7 is real. So I'm going to do 8 plus 7, which I know that 8 plus 8 would be 16. So if it's 8 plus 7, it's 15. And then I do the imaginary part. -I plus 2i. Maybe I'll do orange. I don't know where my orange is. There it is. So I'll do -I plus 2i. Well, negative I plus 2i. If these were x's, I would do negative x plus 2x, which would just be x. In this case, it'll just be I. But what I'm really doing is I'm doing, in this, I'll actually write it out here. So this is 8 plus 7. And this one is like negative 1 plus 2. And then there's like the I on the end, because there's like a negative 1 right here. And there's like a 1 right here. Okay, that was adding. We did it. Ready for subtraction? Let's do 3 plus I minus 5 minus 4i. So the first thing we're going to do, why not just add another color into this? Get ready. Is we're going to distribute this negative into my problem. So I'm basically going to multiply everything by negative 1. Or you can also think about it as changing the signs. So what I really have is I have still 3 plus I, but then I'm changing this to an addition problem by doing negative 5 plus 4i. So I made a positive, a negative, and a negative into a positive. And then I combine like terms again. Same thing, Miss Willard. Yeah, adding is just subtracting backwards. Or reverse subtraction is called addition, as Critical Role likes to say. So 3 plus negative 5 is negative 2. And then, my pens, I plus 4i is 5i. So again, what I did was I did 3 plus negative 5. And then here I did 1 plus 4. Beautiful. With an I on the end. Okay, that's adding, subtracting. Do you want to try multiplying? No, you don't, but we're going to do it anyways. So we can add, subtract, or multiply. Let's do 9 minus 2i times negative 4 plus I. Now, whenever we have two things multiplied together, two things here, we have to FOIL it. It doesn't matter if it's in weird math or in normal math, we have to FOIL them because distributive property, we're basically doing distributive property twice. But some of you, it's been 2 years in a pandemic. So let me just recap what FOIL means. We do the first two numbers together. So I'm going to do 9 times negative 4, which would be negative 36. And then we do the outside numbers. So that's the 9 times I. 9 times I is just 9i. Don't get too caught up on it. It'd be like 9 times x is 9x. I stands for inside. Also, your teacher might have called it outer and inner. It's the same. I don't care. So the inside two are the negative 2i and the negative 4i, which makes a positive 8i. And then L stands for last. And I am running out of colors, but I'll just use this random green one I've been doing. So the last two is negative 2i times I, which is negative 2i squared. Okay. And let me just recap that. I times I equals I squared. I want that to be like locked in here. Okay, and now I just can kind of bind like terms and do one little magic thing, and then we'll be done. So negative 36 right now doesn't have anything to add to it, but 9i plus 8i is 17i. Okay, and now here's the thing that I want you to just lock in. I already said it in the beginning. I squared equals negative 1. Okay, I squared equals negative 1. I put that in a box because I want you to freaking remember it. So what I'm going to do is I'm going to replace this I squared with a -1. Okay, I squared equals a -1. So I take my I squared, I replace it with a -1. Now it's just a normal freaking number. What? So I have -36 plus 17i. -2 times -1 is a +2. And then I'm going to put these two together. -36 plus 2 is -34. And that's my final answer. Okay, next is division. No, I'm just kidding. You don't divide until till pre-calculus. Algebra 3. That's what I was about to say. Same. You're not going to divide until pre-calculus, but don't worry about it. It'll be fine. This is useful because in the last section, in solving square roots, if you got like a -20 here, we would keep going and we would just have 2i root 5. But we're going to officially get to that when we get to next lesson, which is quadratic formula. I'm going to be so excited about that. And so I want you to just right now focus on the operations and don't worry that it kind of feels like it's like a bonus lesson. It's a foundational lesson that I just need to use to get to the quadratic formula, because in the quadratic formula, we for sure are going to have imaginary answers. You're done here, but let me just really quick tell you one thing. So you know, hopefully, that we're trying to find the x-intercepts, right? That's our goal. So normally, we've been finding 2 x-intercepts. Occasionally, there might be 1 x-intercept. And every now and again, there's no x-intercepts. If there's no x-intercepts, our answer is going to have an I in it. And I just wanted you to maybe keep that in the back of your mind. We'll officially do more on it later. But those are our 3 options: 2 x-intercepts, 1 x-intercept, or no real x-intercepts, which is imaginary. All right. I hope you understood this. And if not, please email me or come to my office hours Monday and Friday from 3 till 5:15 and Tuesday and Thursday from 1 until 3:15. Or just email me. Okay, bye.